Hello everyone, so my name is Dayan Brunie and I'm software architect at MetaMask and I'm going to talk with Gloria that is from Karma3 Labs and that is a reputation and trust protocol. So, we want to invite you in our journey to build a trust and reputation mechanism. So, our decentralized society is maturing, and we are now going beyond financial use case, and we are now building, let's say, a social relationship of trust. So we at MetaMask are strongly committed in building a permissionless innovation ecosystem. So the first step to build this is to introduce Snap, that is an ability to extend your wallet. So today, Snaps is an open beta, and we are moving toward a permissionless distribution of Snaps. So today, we need to have a control over the snaps that are distributed because they can have unexpected behaviors. That's where a trust and reputation mechanism is introduced.
Yeah, so maybe I can add a few words there.
Yeah,
so in our daily life, when we make a decision, right, about which restaurants to go to, which books to read, which party to go to, which events to go to. Oftentimes, we actually rely on the people we trust, the close friendship circles, and say, hey, Dayan is going to this cool event, Hyperlink, then I have to go because that's going to be a really cool event. So we base on our social connections to kind of make decisions. But for a very long time, we have gatekeepers, like middlemen, broking, what is trustworthy, what is actually reputable for a very long time as our society growing really big and scale. But MetaMask has this ambition that we're not going to be the gatekeeper only to dictate what is trustworthy, what is not. Let's tap on the community wisdom, the collective wisdom from the people, see what is the ecosystem that can have an organic, sustainable, but also safe mechanism to help people to make trust decisions.
So in this journey, we want to provide some steps in order to move from the overall motivation that drive you in order to build this trust and reputation mechanism until the way you leverage this information. So the idea is to illustrate all this journey with the experimentation that we are doing right now, that is to build a trust and reputation mechanism for snaps. So first, we need to clarify the goal. So what is the purpose? Why do we need reputation and trust in our ecosystem? So Snap is augmenting the capabilities of MetaMask. And today we have a NOLO list in order to prevent unexpected behaviors. We want to have no intermediaries, so we want to rely on the community. So the community will build somehow a trust graph that will be leveraged in order to compute the reputation of each peers, each snap. So our goal is to provide all the reputation insight in order to give all the information for the end user to take informed decision. In this ecosystem that we are building, we have different stakeholders. First, we have the user. So you have the end users that will install snaps. So they need to have the right insight. Then you have the auditors that will audit Snap. We want to provide permissionless auditing. So what do they need in order to audit Snap? What information they need? We also have Snaps developers, of course, that are developing Snaps and that are making grow the ecosystem. And of course, we have all the ecosystem where we are building on, so all the decentralized networks and so on, as well as other stakeholders like regulation, like the marketplaces where we distribute MetaMask with embedding snaps. And we need to clarify the problem statement with high-level requirements. So we want to be censorship resistant. So no intermediaries are able to censor anything. We want to be totally permissionless in all the different dimensions, so auditing, distributing snaps, and so on. Scalable, because at the beginning we might have not so much volume, but it can grow as the ecosystem grow and snaps adoption grow. Data availability and portability. So yeah, here is the scene. So where we start. So everything starts with identity. So yeah, not your key, not your identity. So yeah, today we have identity in all different social networks and so on. But now we have the ability to have our identities that we own. So basically, we have our identity embedded in our public key and all its derivatives. And the private key is the way to control and to prove that you own this identity. Yeah. Identity is about proving who you are. And on top of that, because identity is not some numbers, it means something. And we can choose our preferred own name, like ENS, like lens profile, like forecaster profile, as well as your profile picture in order to represent yourself. So we leverage DID, Decentralized Identifier, in order to be agnostic to any chain. Because in MetaMask, we have the aim to have a multi-chain approach. Capture relevant signals, and here you see the social graph of Gloria, so I give you the floor.
Yeah, GM friends. So I'm Gloria, I'm from Karma3 Labs, and we are building the infrastructure for decentralized reputation protocol for Web3. So Web3 is full of different reputation signals. We already know, like, you have like social network graphs, like Lens and Forecaster. You have proof of membership of different DAOs and different communities, and you have proof of humanity in different ways, like including a couple of providers in the super resistance space. And then you have proof of attendance and contribution credentials that's awarded to individual contributors. So we can capitalize such signals to kind of indicate the trustworthiness of a developer, of a user, and of a snap. But we also need to add some new signals into this because we need to cater for the particular context of safeguarding the snap security. So we need like user trust credentials from different sources, and we also have like the snap version audit credential from a trusted auditor to a snap version, and we have also the review credentials from a user based on the usage experience to issue a credential to this snap as an endorsement or as basically a dispute for the snap version. And as you can see, that the different kind of like credentials, signals, and attestations creates a well-connected social graph. And this social graph basically captured how people actually think about what is trustworthy or not.
So this is my social graph. You can see that we are leveraging existing on-chain data, like social network, social graph, that we can use in order to score the reputation. You have protocol like POAP, like proof of humanity, that enable to give ID on who are this person. And in orange, you can see the new elements that we are introducing. So we have in the Snap that is a new element. So we have created a decentralized identifier for Snap in order to identify it. And then you can use attestation, credential that will enable to anyone to issue assertions about Snap, about a person. So in orange, you can see that, for example, I trust erico.eth. Erico is trusting this account for security reasons, because trust is contextual, and you need to identify on which quality you trust which person. Then you have the Snap audit credential that is also kind of attestation and review. And all this information are the key data points that we will use, and people will be able to endorse or dispute them. And this is building all these graphs. So you can see on the top right some bad behaviors that have been identified according to my trust graph, because it's relative to each of others. And here you can see that here these people have no social link with me, and they are distrusted by people that I trust. And they also issue like a snap that he looks vulnerable. And then here it's a pattern that looks healthy. So I can trust this snap because people that I trust are trusting this snap with some indirect and direct information. So we need to store somewhere all this data. So in terms of requirement, we want to be scalable. We want everything to be verifiable. So who has issued what, censorship resistant and highly available, and of course portability to don't be locked in any protocol. And today we use blockchain for everything, but in all the web, you have so much data. And here we might have so much more data that a blockchain can handle, because they have strong consensus algorithm, and they are not enabling to scale for some kind of data. Some kind of data needs blockchain for protecting for double spending and so on. So here we have Ceramic, for example, that is a more data storage, decentralized data storage solution. Verax is an example of attestation registry that enable to issue information, assertion about anything. Let's speak about the computation of all this information in order to have the trust score. Gloria?
Right. So one of the key elements for what we're building is to have a recursive trust computer taking these like implicit and explicit trust signals. And as a protocol, we'll be also decentralizing the compute over time. So what are the important elements? Of course, we already have the data layer, which is very readily available for us in Web3. And then we want to also do a open and verifiable, composable algorithm layer that basically computes this data in a trustworthy way. There are two important things here. One is we utilize the eigentrust score computation, which basically defines trust in a peer-to-peer sense, and then use that sort of social graph signals to have like a reputation as an emergent property of social interactions. But we also place the seed trust in the computation to put in the specific context, because trust is always subjective to some degree, but that needs to be kind of like defined by the community already trusted people, that they are kind of like safeguarding it, and that's the seed trust concept in eigentrust. And then we weight the reputation of the people who basically signal trust into the snaps. So this way, even if you have like 1 million Sybils, but they have no reputation in the network, then whatever they say about a snap is not going to be counted significantly at all. So in this way, we can have a verifiable compute for the snap versions and in a decentralized way.
Wonderful. So yeah, it's recursively computing all the nodes of the social graph coming from the snap as a root, and then going to the audit, review, and endorsement dispute of them, and then you process for each issuer their reputation, and you have the weight. So here is a global picture. I won't go too much in detail, but yeah, from signals that we are capturing from different sources. So first we have the on-chain information, but today we have snap directory that are introduced by MetaMask, but also by the community. We issue credentials from there that we will store in the data store, and the idea is to be able to get the information from a trust computer, but the idea is to be open to any kind of algorithm that will compute this kind of information. And the final trust will be read by the Snaps directory to give insight to user, but more importantly in MetaMask in order to give the right insight for them to take the decision to install or not a snap. We will also enable any end user to choose the trust level they want in the ecosystem to see the level of risk that they are willing to take. And the snaps registry, that would be a decentralized registry based on smart contracts that will issue a decentralized identifier to each snap. So here we go. Now that we have the reputation score, what should we do? Because the reputation score is not very readable. So we need to contextualize this. We need to provide the right user interface, the right user experience in order to offer the right insight to take decision. So we are working with IDEO, for example, Karma3 Labs, and so on, to design an ideal experience, a frictionless user experience, in order to provide the best insights, the best information to help end user take informed decision. Thank you.
Thank you very much.